This video is a tutorial on calculating nuclear binding energy. For an example problem, we'll be using problem from chapter 1968A. Calculate the mass defect and nuclear binding energy per nucleon of lithium-7. Atomic mass is given. In doing these problems, the first thing to do is read it carefully. The first question is, what are they asking you to find? In particular, note on this question is that they want the energy per nucleon. The other item of note is that it gives us atomic mass. These are important keys to know which set of calculations you should complete. Sometimes instead of atomic mass, a problem will give you nuclear mass. This is only the mass of the protons and neutrons. Since this problem uses the atomic mass, the first thing we need to do is figure out the change in mass between the subatomic particles and the mass of the atom as a whole. In this problem, we're using lithium-7. First thing we need to do is look at a periodic table and determine how many protons and neutrons we're dealing with. Lithium is in the first column of the periodic table. Its atomic number is 3. So it has 3 protons and 4 neutrons. Since it has 3 protons, we also know that it has 3 electrons. We then use the mass of these subatomic particles times the number of them that are present to determine the atomic mass of the pieces. These masses are given in your textbook and also in the notes from class. Notice that we need to use a large number of significant figures on these problems, as these mass changes are very small. I've gone ahead and plugged these into the calculator. You can pause and confirm that you get the same numbers with your calculator. Now, to find the change in mass, we look at the difference between the mass that was given and the mass that we just calculated. Notice we probably should have used one more significant digit in our masses of our AMUs, as the number they gave us had one more than we calculated. So we are going to lose a sig fig, which is never a good thing. Since we lost a sig fig, we need to round to that decimal, making that a 3 and dropping the 7 at the end. This is our change in mass. Now, to find the change in energy, we use the famous equation, delta E equals delta mc squared. Now, notice we currently have mass in AMU. AMU is on an atomic scale. The question in our book and on the sapling homework asks for it in joules. It is more convenient to use the molecular level, the world we live in and can weigh, the gram basis scale. And by definition, 1 AMU is the same as 1 gram per mole, and that is by definition, so it's an exact number. So we have 0.04213 AMU is the mass difference. And we know that there is 1 AMU is 1 gram per mole. So now we've got it in terms of things that'll get us to joules, which is the units we want our answer in. Notice once you've learned that, you can just write it down and know it without having to show it in a separate step. Now recall, joules has units of kilograms per meter squared per second squared. We have grams, so we need to convert from grams to kilograms. Let's review some calculator operations. So to do the exponent, we use the EE button. And to square it, there's a squared button. Now we can input the rest of our calculations. And write down our answer. Notice we have 1, 2, 3, 4 sig figs in our mass difference. Notice we started with numbers that had more than that, had 1, 2, 3, 4, 5, 6 sig figs. There is a loss of sig figs while you're doing this problem. Now careful, what are our current units? Our units are, yes, joules, because we've got kilogram, meter squared, second squared, but we also have this per mole. And it's per mole of what? It's per mole of lithium atoms. Our problem asks per nucleon. We need to get from mole of lithium atoms to nucleons. I'm going to rewrite just for the sake of space. This is why it is also incredibly important to always carry all of your units so you know what your units are. 1 mole of anything is the same as 6.022 times 10 to the 23rd of whatever that thing is. Notice that gets rid of our moles. We still have lithium atoms. And every 1 lithium atom, how many particles are in the nucleus? Since it says per nucleon. Nucleons include neutrons and protons. We looked up earlier, we can tell from the mass number that there are 7. We could also get that from adding the neutrons and the protons. Now notice I left my number in the calculator so I can just continue inputting. And I get a final answer of 8.98 times 10 to the minus 13th joules per nucleon.